Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. You should start thinking about subtraction as representing a distance between two points on the number line. The result of the subtraction will be positive as long as you're going right minus left, meaning the bigger number, the number that's further to the right, minus the number that's to the left of it, that's always going to be positive regardless of where 0 is. In fact, the position of 0 is totally irrelevant when it comes to a distance between two numbers on a number line. And when you're subtracting a smaller number from a larger number, you'll get a positive result. And if you're subtracting a larger number from a smaller number, you'll get a negative result. And whether those numbers themselves are positive or negative is irrelevant, because that would just be based on the position of 0. And the position of 0 is not interesting if we're talking about subtracting one number from another. The position of 0 is not interesting, and I think that's what's holding you back there, Himanshu. When you were in elementary school, you were taught that if you want to subtract, say, I'm just coming up with some random example here, right? So what were you taught? I'm assuming you were taught this. You were taught, okay, 2 minus 9 doesn't work, so I need to borrow a 1, right? And 12 minus 9 is 3. Now, because I borrowed a 1 from here, this is now only 2. There's only 2 left there. So again, I have 2 minus 9, which doesn't work. So I'm going to borrow a 1 from here, right? So now I have 12 minus 9 again. That's 3. And here I only have 6 left over because I borrowed a 1, and 6 minus 4 is 2. This is how you were taught to do subtraction, correct?
Yeah, correct. Exactly.
Yeah. I think it's a real shame that you were taught it that way. By the way, I was taught it the same way, because by teaching you that, they robbed you of the opportunity to improve your quantitative reasoning, which would look something like this. You'd say, hey, this is just 1 below 500. This is 32 above 700. So obviously I have a 200 difference there, and I'm going to add a 32 here and a 1 here, so that's 233. Done. Now, it's not about whether this is faster or not faster than what you were taught. And I don't care so much about the speed. I care more about the visualization and the quantitative reasoning. Now, if you were doing it that way, then later on, when you had something like negative 15 minus negative 60, what would you do? You'd say, okay, here's a number line, here's negative 15, here's negative 60, and the difference between them is 45, because that's going to be negative 20, so that's 40, and that's 5, so 45 is the difference. And where is 0 on this number line? Who cares? Who cares? A difference, a subtraction, is just how far apart are the things on the number line. And if you had, I don't know, negative 7 minus 30, right? What would you get? Well, this time you're subtracting the bigger number from the smaller number. Now the distance between them is very easy to see, is 37, because you've got 0 there, so 7 to the left of 0 plus 30 to the right of 0 is 37. But because you're subtracting the bigger number from the smaller number, the answer is going to be negative. And where is 0? Who cares? The answer there is negative 37, because the distance between the numbers is 37. And why is the answer negative? Because you subtracted the bigger number from the smaller number, so of course you're going to end up with a negative number. I remember when my son was 4, he woke up in the middle of the night, and children do that sometimes, and they cry, and you have to go comfort them. And he asked me, just randomly, he said, what's 4 minus 9? So this is the first time that we had to talk about negative numbers, and he knew that 9 minus 4 is 5, but then he was wondering, how would you go the other way around? And I told him, let's grab a ruler. So we took a ruler, and he showed me on the ruler how 9 minus 4 is 5, right? He started from 9, and he counted 4 units to the left and got to 5. And I said, well, how would you do that with 4 minus 9? How would you do that? So he found 4 in the ruler, and he started counting 9 units to the left from 4, but he ran out of ruler, right? So I said, okay, let's take the ruler to the mirror and put 0 right where the mirror is. And I said, okay, look into the mirror. Do you see that the mirror also has a ruler now? Like, there's a physical ruler that you're holding in your hand, and then there's the mirror image of that inside the mirror. Now you can keep counting past 0. So again, he found 4, and he started counting 9 units to the left from 4, and continued to count into the mirror until he got to 5 in the mirror. And so he looks at me all confused, and he says, wait, so the answer is 5? And then I told him, no, the numbers inside the mirror are called negative numbers. And he goes, oh, so it's -5. And that's how I taught him about negative numbers and about how do you subtract a bigger number from a smaller number. But that's essentially what we're dealing with here, right? The result of the subtraction will be negative if you're subtracting the bigger number from the smaller number. And it will be positive if you're subtracting the smaller number from the bigger number. But the magnitude of the difference is just how far apart are those numbers on the number line, and the positioning of 0 is not interesting in this context. The position of 0 is only interesting in multiplicative reasoning, because there it's all about the distances of the individuals from 0. But in additive reasoning, 0 is not an interesting point in the number line. I think the benefit of doing it with a mirror is it opened his mind conceptually to the negative side of 0, like to a whole other side of the number line, which I would have missed out on if I had just said, oh, just look at how far apart they are from one another and put a minus in front of it if it's, you know what I mean? Like that's more of a rote memorization kind of thing, and it's lacking some of the reasoning that I think I managed to, or let me put that another way. It's a different perspective, right? You could say, look, subtraction is always just talking about the difference between two numbers on a number line, and depending on which direction you're going, it'll be either a positive difference or a negative difference, right? And that's a valid perspective, and I think is good to teach as well. But that in and of itself is not sufficient, because then you miss out on the whole negative side of the number line and the importance of where 0 is, and et cetera, et cetera. Once we get to multiplicative reasoning, my son and I, actually we're already there because he's doing the times table, then the position of 0 is very important. Everything to the left of 0 is the mirror image of everything to the right of 0, right? So just as an example, a lot of people get tripped up here because 7 is greater than 4, obviously, but -7 is actually less than -4, and that's why if you multiply an inequality by a negative, the sign of the inequality flips. It's because of this mirror image. It's the same principle as if you're right-handed and you're brushing your teeth and you look in the mirror it looks like you're using your left hand to brush your teeth. So everything is opposite. So here's 4, and now I'm going to do -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And where did I get to? If you're looking at the ruler in the mirror, you'd see that you got to 5, but since it's in the mirror, it's -5. We went to a restaurant and we had to go downstairs to the basement to wash our hands before we ate. So we're walking down the stairs and there was a mirror on the stairs, and in the mirror we saw the reflection of a painting that was behind us. It was a painting of a boat. So there's like a picture of a boat, but we were seeing it in the mirror, and he points at it and he goes, look, it's a negative boat. I just thought it was so cute. He was 4 and a couple of months old. He was very, very little at the time. So cute. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.